concrete is a versatile construction material. It is widely used in various structures. To achieve the desired structural and functional properties of cement concrete, it needs to be scientifically designed. To design the cement concrete, it is necessary to study its basic ingredients and basic concepts. The basic ingredients are cement, aggregate, and water. The basic concepts are water-cement ratio and workability. Cement is tested for its standard consistency and setting time by Vickert apparatus. The soundness of cement is tested with the Le Chatelier's mold. The most important property of cement for structural use is its compressive strength. It is determined by testing of cement sand mortar cube in the compression testing machine. Coarse aggregates are either obtained from crushers or from the riverbeds. The important properties of coarse aggregate which affects the concrete are the size and shape of the aggregate particles. Excessive flaky or elongated aggregates are not good for quality concrete. Other properties which influence the properties of concrete are surface texture, strength of aggregate, specific gravity, bulk density, etc. Bulking of sand is a property which affects in case of the volumetric batching of the materials for cement concrete. For finer sands, the bulking is higher than for coarser sands. Grading of aggregate plays an important role in mix design. It can be determined by sieve analysis. Graded aggregate has lesser voids and is better for cement concrete. Grading curves are used for proper grading of aggregates for the concrete mix design. A very important concept affecting the strength of cement concrete is the water-cement ratio law. It states, with the given concrete materials and conditions of test, the quantity of mixing water used alone determines the strength of concrete so long as the mix is of workable plasticity. From the curves, it is evident that higher the water-cement ratio, lesser is the strength. Concrete density ratio versus strength ratio explains the importance of compaction for concrete strength development. A reduction of 5% in density results in 25 to 30% reduction in strength. Thus, workability is another concept which plays important role in concrete mix design. Workability is the ease with which concrete can be placed, molded, compacted, and finished without segregation and bleeding. One simple method to judge workability is the slump test. Slump is measured as subsidence of wet concrete from the top surface of cone when it is lifted. A better method of judging workability is the compacting factor test, which is very useful for relatively dry mixes. For workability, the surface area of aggregate plays important role, which depends on size, shape, and type of aggregate. Greater the size of aggregate, lesser is the surface area per unit volume. Rounded aggregate has a lesser surface compared to crushed aggregate of the same size. This may be explained by considering a cuboid of 2 centimeter size broken into 8 cuboids of 1 centimeter size, having total volume of 8 cubic centimeters in both the cases. The surface area for one 2 centimeter cuboid is 24 square centimeter, while that for 8 cuboids of 1 centimeter size is 48 square centimeter for the same volume. For different jobs, concrete of different workabilities are required as indicated by slump values. The greater the surface area of aggregate, the more is the quantity of water to achieve the desired workability. Central Road Research Institute has developed water and sand requirements for a set of conditions. For other set of conditions, these requirements should be modified. Indian Standard Special Publication 23 also provides table of requirements of water and sand proportions for water-cement ratio of 0.6, compacting factor of 0.8, and sand of grading zone 2. These requirements can also be modified for other set of conditions. Objective of mixed design are to achieve desired workability during plastic stage, desired strength in the hardened stage, maximum economy in proportioning of cement concrete. The factors such as water content, influencing workability and strength, are contradictory, and therefore to achieve the objectives of mixed design, a certain compromise and optimization are required by trial mixes. Cement concrete mixes may be prepared as nominal mixes, that is ordinary concrete, or as design mixes, control concrete. Nominal mix proportions are not based on rigorous testing, but are based on experience and approximations. These proportions may be used for small and less important jobs only. For important and large jobs, it is necessary to design the concrete mixes on sound scientific principles of water-cement ratio, workability, etc. Mix design consists of determining proportions of various ingredients so that the resulting concrete satisfies the requirement of plastic as well as hardened concrete. Mix design procedure involves in finding target strength on the basis of characteristic strength and quality control at site. Type of cement, target strength helps in deciding water-cement ratio. Size of section, spacing of reinforcement, maximum size and shape of aggregate, grading zone of sand, compaction method, and workability requirements, along with water-cement ratio, helps in deciding water content and sand proportion. From absolute volume, the aggregate content and mix proportions are decided. Mixer capacity helps in deciding the batch proportions. Control conditions, characteristic strength, workability requirements, and actual material specifications are thus essential parameters for concrete mix design. The concrete mix design procedure can best be understood through an example. A concrete mix M25 is required for a project where low workability, good quality control, and moderate exposure conditions are expected. Tolerance level of 1 in 15 and coefficient of variation of 10% may be assumed. Constant and standard deviations may also be assumed from 1S SP23. The materials available at site are cement of 7-day strength of 27 MPa and specific gravity of 3.15. Coarse aggregate is of 20 mm size, crush type, and has specific gravity of 2.7. Sand is of grading zone 3, having fineness modulus of 2.2 and specific gravity of 2.6. Step 1. Design target strength. S is equal to S bar divided by 1 minus T into V by 100. T is equal to 1.5 for tolerance of 1 in 15 and testing of large samples. Therefore, target strength S is equal to 29.5 Newton per square millimeter. S is equal to S bar plus K times standard deviation. From Indian Standard, Special Publication 23, constant K is equal to 1.65 and standard deviation is equal to 5.3. Therefore, S is equal to 33.7 Newton per square millimeter, approximately 34 MPa. Step 2. water-cement ratio comes to 0.42. For moderate exposure condition, maximum water-cement ratio is equal to 0.55 for RCC. Step 3, water content and sand proportion. For 20 mm crushed aggregate, for desired compacting factor 0.8, sand conforming to zone 2 water content is equal to 186 per cubic meter. Sand as percentage of total aggregate P is equal to 45%. Thus, P is equal to 40. Step 4. Cement content is equal to water content divided by water-cement ratio is equal to 443 kg per cubic meter. Step 5. Aggregate content. For 20 mm maximum size of aggregate, the amount of air entrapped in wet concrete is 2%. By absolute volume equation we have substituting the values of V is equal to 0.98 cubic meter, and solving equation gives Fa is equal to 680 kg, Ca is equal to 1060 kg, water 186 liters, cement 443 kg, fine aggregate 680 kg, coarse aggregate 1060 kg. Step 6. Adjustments in the field. Above concrete mix design is based on surface saturated condition of aggregate, and hence for any other moisture condition of aggregate, the volume of water and masses of aggregate should be adjusted on the basis of field observation.